Sandia's biomass program is really focused on a system of systems approach to converting a variety of different feedstocks into renewable fuels and chemicals. The two primary feedstocks are lignocellulosic biomass and algae. And in terms of the lignocellulosic arena, we've really focused on developing advanced technologies that can break down biomass and liberate fermentable sugars from that resource, and then developing a new toolbox to transform those intermediates into fuels. We also have a rather pioneering program on lignin conversion, which is one of the biggest commercial bottlenecks to biofuels today. And we're really focusing on both biochemical and chemical approaches to convert that into renewable fuels and chemicals.
The second generation biofuel has a lot of potential to replace the current transportation fuel that is petroleum derived. And there are a lot of researchers, they are working towards this goal of replacing petroleum fuel. And there has been tremendous progress made, but there are still some current challenges that must be overcome.
One is the fact that production in and of itself is low, so the sort of instantaneous production of the algae is very low. And the other problem is the sustainability of the system. So algal ponds, particularly open ponds, will crash for a variety of reasons. And we're interested in understanding why the ponds are crashing, how we can predict this, and how we can actually create countermeasures to prevent the crashing of the ponds.
What we're trying to do is create an early warning detector that allows us to determine if something in the pond is of concern and needs to be investigated further.
We're working on projects that will enable us to accept a variety of different algae sources with various biochemical compositions and convert all of those major fractions into fuels. That includes algae polycultures, more conventional monocultures, and also benthic algae that haven't been explored in high detail yet. Our processing modules should be agnostic to the composition of the biomass, but we have to modify those and adjust those based on the feedstock supply that we're receiving. Just maximizing fuel yield based on the total biochemical composition is our overarching goal.
Taking a success at the bench and translating it into a pond is really one of the biggest challenges that we face. And why we have these enabling technologies around microsystems, around remote monitoring, around tracking the health of those algae living in that system, we're able to troubleshoot it in a rather straightforward but elegant way, and in a way that is very enabling and powerful. In lignocellulosic biomass, it's really overcoming the recalcitrance of the plant cell wall to conversion. And you can do that in lots of ways. One is you can try and engineer or formulate a better feedstock. What we've really focused on is developing better conversion technologies that can overcome the recalcitrance of the plant cell wall, be it in any mixture of feedstocks or any single feedstock.
Almost close to 60% of this raw material cost is due to the feedstock. So this is one of the current challenges towards enabling biofuels from lignocellulosic biomass. So what we are working on, basically blending these lignocellulosic biomass with municipal solid waste. And the reason we want to tap into municipal solid waste is basically they are cheap, they are currently available, basically there is established infrastructure for its collection already. We are trying to understand that whether we can use this municipal solid waste with lignocellulosic biomass as a blending agent and do a formulation that meets the specification for the biofuel industry.
The broader national security mission, or at Sandia we call it a secure and sustainable energy future. Biofuels have to be a part of it for several reasons. One is to meet the greenhouse gas emission reduction standards as established in the Renewable Fuels Standard. The other is to meet the volumetric production targets under that same piece of legislation. You need to have a lot of conversion technologies that are deployed to create a fault-tolerant energy generation system from a biological source. We also have the combustion research facility out here in Livermore. And by combining advances in biofuels with advances in combustion performance, we actually get the opportunity to go after what we call the co-evolution of fuels and engines that drive not only reductions in greenhouse gas emissions generated by the biofuels, but also gains in fuel efficiency and engine efficiency that are required by the new CAFE standard legislation. It's a really good confluence of policy and science drivers that are at the core of why Sandia cares about biofuels.
Sandia is uniquely positioned to take on the economic challenges to algal biofuels production because of the multidisciplinary nature of the laboratory itself. We have engineers working in close proximity, hand in hand with biologists to tackle some of the challenges that inhabit both the biological and engineering spaces. So we're able to utilize technologies that have been developed at Sandia for different purposes under different programs and leverage those into challenges that are specific to the algal biofuel space.
We're looking at whole biomass valorization from renewable resources, be it lignocellulose or algae. And we're trying to diversify the product streams that we can realize from those resources to meet a variety of different market needs, be it fuels, be it chemicals, be it polymers, or specialty materials. And so we're really trying to develop this system of systems approach to valorizing different product streams from sustainable feedstocks, and not looking for a silver bullet, but really looking for a silver shotgun to help answer the nation's energy needs.